Hey guys, we're going to do these examples. Same concept, but they're not set up in y equals mx plus b form. Well, we need to remember if it's less than or greater than without the line underneath, dashed line. If it's less than or equal to, greater than or equal to, that's our solid line. And wherever our palm is, if it's less than, we're shading under. If it's greater than, we're shading above our hand. Okay, so they were a little bit of reminders. So this is in standard form, not in y equals mx plus b. So recall that when we had an equation given to us in standard form, I know it's an inequality now, but we're going to do the same thing. So we need to get y by itself on the left. And in order to do that, you need to move this x. So anytime I circle a term, it means that I'm changing the side of the equal sign, or in our case now, the inequality that it's on. And I'm going to change the sign that it has. So here, it's positive 8x. So when I move it to the other side, it's going to be negative. So let me just type this in here. So we have 8x, or I'm sorry, we're moving our 8x. We have 6y. I'll write that in. Greater than or equal to. Let me write it in here. And now I'm moving my 8 over. So 8 was positive on the left. So over here on the right, it's a negative 8x. Extend this, I'm sorry. And then you just bring down your 12. It's a positive 12, so I'm going to write plus 12. Oh my goodness. All right, there we are. Okay. Now, this is not an equal sign, it's an inequality. So if I have to divide by a negative number, I need to change this inequality. So the number that I'm dividing everything by is 6. Because it's a positive number, I don't have to flip my inequality. Okay. If this was a negative 6, I would flip this from a greater than symbol to a less than symbol. That's not the case here. So I have to divide every single one of these terms by 6. So 6y divided by 6. Oops. We have negative 8x divided by 6. And positive 12 divided by 6. When we do that, y is by itself. I'm going to skip a space so I can put my inequality. Negative 8x over 6 reduces to negative 4 over 3. And 12 divided by 6 is positive 2. Let me put my inequality in here. Alright, so now this is in y equals mx plus b form. Now I could notice that it has a line underneath, so it's going to be a solid line. And now I could identify my m and my b. So my slope here is negative 4 over 3, and a negative in the top means you go down. In the bottom, you're going to go right. Or you could do the opposite. You could go up and to the left. My b, or my y-intercept, I'm just going to type it here, is 2. So I begin at b, which is 2. So that's up here, 1, 2. You put your dot. Then I'm going to go down 4 into the right 3. 1, 2, 3, 4. Into the right 1, 2, 3. From 2 I could also go up 4. 1, 2, 3, 4. And to the left 3. 1, 2, 3. You could continue that process. I could go up 4 more. 1, 2, 3, 4. And to the left 3. From here I could go down 4 more. 1, 2, 3, 4, and to the right 3. So you could continue if you wanted to, just to have a straighter line if you're doing this freehand. I have a computer's help, so My job is a little bit easier. So we're going to connect these dots with a solid line because there's a line underneath it. So the line is included in our solution. Okay. It is greater than. So if I have greater than, when I put my hand over this line, so I'm going to take my right hand, I'm going to put it over top of this line, and if it's greater than, you shade above it. So if I have my right hand over this line, above my right hand is all of this area right over here. Okay, that's on top of the line. So all of this that I'm shading in, including that line, is a part of my solution. That means that any ordered pair in the shaded region or on the line, if I were to plug it in for x and y, will give me a true statement. For example, so I pick this point right here. This point is, let me change it to this so I can write nicer. This point right here is 1, comma, 1, 2, 3, 4, 5. And if I were to substitute these values in for x and y, I'm going to get a true statement. So if I were to do that, let's do it with red. I'd have 8 times 1, because 1 is x, plus 6 times y, which is 5, greater than or equal to 12. So 8 times 1 is 8, plus 6 times 5, which is 30. So 8 plus 30 is 38, and 38 is certainly greater than or equal to 12. So that's a true statement. So I did shade the right side, or the correct side of that graph. All right, let's see another one. All right, here's another one, not in y equals mx plus b, so you need to change it. So every single time you're going to get rid of this x first. When you circle it, you change the side that it's on and the sign that it has. So I'm going to bring down my negative 7y less than, and if it's positive on the left, over here on the right, it's negative. So negative 3x, and bringing down my negative 21. Now, this is what I was talking about before. If you have a negative in front of y, that means that you're going to be dividing everything here by a negative. If you divide over the inequality by a negative number, you have to flip your inequality. So what I mean by that is, instead of it being less than, when you're graphing this, you're graphing, it should be a y. Y is greater than. Okay, so you have to flip your inequality anytime the y is negative here. Okay, so if the y is negative, you're going to flip this, because you're going to have to divide everything by a negative number. And if you recall, back when we were doing inequalities, you have to flip that. All right? So you're dividing everything here by a negative 7. So this by negative 7. This by negative 7. And this by negative 7. Let me make this look nicer. I'll type it up. So y, instead of less than, is greater than. Negative 3 over 7. Negative over a negative, that becomes positive. Oops. Negative 21 divided by negative 7 is positive. So you have a greater than symbol without a line underneath it. That's a dashed line. And this is what I'm going by. I'm going by what I'm boxing in. So I'm going by the greater than symbol, not the less than symbol. You go by your answer. Okay? So my slope here is positive 3 over 7. It's an equal sign. So positive 3 is up. 7 is to the right. And my b, or my y-intercept, is 3. I got ahead of myself there. Instead of going up and right, I could go down and left. Okay. B is where I begin though, so I'm beginning at positive 3. So up 1, 2, 3. I could go up 3 more. 1, 2, 3. And to the right 7. 1, 2, 3, 4, 5, 6, 7. I could also go down 3. 1, 2, 3. And to the left. 1, 2, 3, 4, 5, 6, 7. It's easier if you count it with your fingers. I just wanted to show you my counting. Dashed line to connect these dots. Just to extend it. And now, if you put your left hand over top of this, it's greater than. So if it's greater than, you shade above. So everything above my hand is right here. Alright. That means if I were to pick a point anywhere up in the shaded region, it will give me a true statement. So let's see. Let me pick, I don't know, this point right here. So this point right here is 0. X value is 0. Oh, let me change my color to black. Y value is up here 1, 2, 3, 4, 5. So if I were to substitute 0, 5 into my equation, either this one, or this one, it's going to give me a true statement. So let's see if I did it right. So 3 times x, so 3 times 0, minus 7y, so 7 times 5, is less than negative 21. Let's move this a little bit so we can see it. There we go. Sorry. So 3 times 0 is 0, minus 35. So we have negative 35 is less than negative 21. And guess what? That's true. So we shaded it in the right area. I know I'm right. This graph represents this inequality. All right. We use the greater than symbol because you go with the one that's in y equals mx plus b form. Okay. You go with the inequality when it looks like y equals mx plus b. This does not look like y equals mx plus b. Therefore, I did not use the less than symbol. This looks like y equals mx plus b. Therefore, I used the greater than symbol that's here. All right. That pretty much sums this up. Hopefully it was helpful. See you guys in the next one.